Well, hello. I'm very happy to be here again. I feel myself sitting in a virtual UHSK-kamer, and I've big memories, great memories to my days and 1998 and 1999, which is now called the 73rd board, but that's a kind of post-Marxist invention of tradition, I would like to say. But I'm very happy to be here. I was attached to the history department, especially political history, until January last year. I've since moved to the history of science group at the science department, where I'm working on my VENI project on the history of German atmosphere physics. So we're going from German biologists on the sea, we're going to Germans in the sky. And but to comment on the two earlier talks, I think this really connects. I did some earlier research. I did a dissertation on the history of Dutch laboratory biology, and it was connected to, of course, the history of agriculture, tropical agriculture, and it was connected to the history of Ernst Haeckel's developmental biology. Yeah? So it's a book, you can buy it, but it's as you can see, Haeckel is also there, and I think Haeckel is one of the most underestimated German thinkers of the 19th century. But we're going to move to a more, we're going to current affairs, and maybe some of you have already noticed the Americans put again a vehicle on Mars, and there were applause. There was a celebratory event, of course. We have already seen a first picture, and what interests me most actually is another kind of instrument that's attached to the Perseverance rover, and it's called Ingenuity. It's a technological test. They're not going to do real scientific experiments or measuring with it, but they're going to test if this thing can fly. And this is really interesting because, well, I mean, I now have to read it from the NASA side because it's the prose is meaningful, I think. Ingenuity will attempt the first powered, controlled flight on another planet, a feat with a high degree of difficulty. Mars has beyond bone-chilling temperatures with nights as cold as -130 degrees Fahrenheit, -90 degrees Celsius. At Jezero crater. These temperatures will push the original design limits of the off-the-shelf parts used in Ingenuity. Tests on Earth at the predicted temperatures indicate they should work as designed, but the team is looking forward to the real test at Mars. One of Ingenuity's first objectives, when it gets to the red planet, is just to survive the frigid Martian night for the first time. We will know today if it survived. Mars has a rarefied atmosphere, just about 1% of the density of our atmosphere on Earth. Because the Mars atmosphere is so much less dense, Ingenuity is designed to be light, with rotor blades that are much larger and spin much faster than what would be required for a helicopter of Ingenuity's mass on Earth. Mars does give the helicopter a little help. The gravity there is only about 1/3 that of Earth. That means slightly more mass can be lifted at a given spin rate. Ingenuity will attempt to 5 test flights within the 30 Martian day, 31st Earth day demonstration window. Its pioneering activities, quote, it's a very important quote, its pioneering aspirations are similar to those of the Wright brothers flyer, which achieved the first powered controlled flight on Earth. So I think this is a real interesting aspect. You see a whole machine, a whole research machine, and you see it combined with prestige, and in this case, American nationalism. But what interests me the most is the atmospheric element here. It's not just about space anymore. It's about a completely different environment. It's about the air, the atmosphere. And today's talk is going to be about this aerial environment and the researchers that studied this aerial environment. And I think I want to be writing a kind of book that other historians have been written about space during the Cold War. I'm going to write a book about the history of air exploration through meteorological instruments in the early half of the 20th century. So I have this project. It's been funded by the NVO Foundation. It's on the colonial stratosphere. It's about Germany, the European state system, and the geopolitics of climate science between 1871 and 1945. And I think it's highly relevant. We have, of course, the space race. It's not just the Americans. It's also the Chinese. It's the Saudis. It's the Japanese. It's Europeans. It's the Russians. We have another interesting new domain, a new space that people want to conquer, the cybersphere. We have, of course, the changing environments because of global warming, because of other climatic changes. And, of course, that, for example, the opening up of the polar seas. We see a Chinese ship here. And I think that we could look at this environmental domain claiming we can, we learn from, as what Lisbeth van der Gift also called, the path dependencies in the past, right? We can learn from, or we could look and watch more closely what was done in an earlier phase in history when the air was being conquered or claimed. So what I'm going to do today is I'm going to talk about the history of German atmosphere physics for a long time, and after that I hope that I have some time to also discuss more current things like the importance of an atmospheric sensibility for historians, the aerial history as a form of environmental history, and I would like to end with maybe some future programs in the history. I would like to investigate the possibilities, and you can help, students, you can help. I would like to study the aerial history of the Netherlands, so going back from Germany to the Netherlands. Last week at the Descartes Center, of which I am a member, and many of us historians who deal with the history of knowledge and science and the history of humanities are also members of, organized a Anthropocene conference and the history of the Anthropocene. And the discussion there was, does the Anthropocene change our practice of history? We will come back to that in the panel. But Jürgen Renn, a German historian from the Max Planck Institute, proposed a very provocative thing here. He said, well, actually, history of science, among other forms of history and among other forms of the humanities, and maybe knowledge in general, should become part of a science of time to better understand the techno-Earth system interaction. I think history of science should, of course, engage with the Anthropocene, but not become part of an Earth system science machine itself. I'm very much interested in the origins of that machine, the origins of the vast machine of the Earth sciences, satellites, computers, observing systems, data productions, international infrastructures, diplomacy that goes with it, and globalism, the scientific ideology of globalism, which is an interesting and a very powerful ideology, which is worth studying, as you would agree. And I think this is still a traditional, but I just think it's still a legitimate mission of the history of science. It's maybe you could say it's too Holocenic, but why not try to keep certain traditions? But I think the Anthropocenic way of doing history is interesting, is an interesting challenge for us. I think we should all, and to quote Bruno Latour's Critical Zones catalogue that appeared this summer, I think we should all land on Earth. Historians, scientists, philosophers, artists. And I think we should all work together and radically change our nature-human dualism. I think we have to all accept that we're part of a critical zone, that we, humans, non-human animals, plants, microbes, the oceans, the atmosphere, are all bound to each other, and that we in a way, we also need to act now. But in a way, I'm also a bit of a stubborn historian, as many of you probably are as well. And I think still the main task of historians is to understand and, if possibly, explain why people fucked up the planet in the past in the first place. And before you think, oh my God, I used the F word on the slide, this is allowed in academia. My mission would be, and I wrote about it this year in an article on COVID-19, my mission would be that, and I think the goal of environmental history in general should be to explain why these earthbound people, animals, plants and microbes keep launching into the atmosphere in the first place. Why the air is such an important agent is, of course, my specific sub-interest. But I think we should keep watching the experts, and that's I think the continuing role and tradition, I would say, and radical tradition of the history of science. So, okay, the history of German atmosphere physics. We might take a small, I wouldn't say a small break here, but we might take some time to think about the images we have when we think about atmosphere physics, or when we think about climate science or meteorology. We tend to have two extreme images, maybe. At the one hand, we have a kind of meteorological machinery. So these are the visions that meteorologists dreamt themselves in the halfway the 20th century. In the end, there would be a big kind of weather machine that was able to observe the Earth. But at the same time, we also have this romantic idea of romantic exploration. It's a tradition to which also Ernst Haeckel belonged, but it's also a tradition that is, well, made famous actually by Alexander von Humboldt. You see him here at the right. But I think both traditions, both images ignore the historical and diverse nature of maintenance work to keep both this machinery and fieldwork, well, at work, right? And I think we have to more closely look into these practices and the differences between them. We have different forms of knowing, different forms of knowledge. We have people manipulating air in laboratories or in rooms, in demonstration rooms at the one hand, and we might think of ballooning expeditions studying the air and the atmosphere in the open field at the other hand. We all have to remember and be very clear that this is part of a larger system that needs to be maintained, or that was maintained in a certain part in history. So we see some examples here of the German Aeronautical Observatory of Lindenberg, where they where they established an aeronautical observatory in 1905. So I'm very interested in how these kind of practices emerge out of one another. So how one form of science creates a new form of science, how the science keeps emerges as a kind of self-reproducing machine itself. And I think a good moment to start, a good point in history to start and looking at these systems and machines is, I think, the Cold War. And I would like to focus on a very specific project, the Global Atmospheric Research Program, which was a program by the World Meteorological Organization, an organization allied with the United Nations, to study the tropical atmosphere. And as you see here in the imagination, you can compare the imagination of this project with the imagination that NASA is now producing with the Mars program. You see the collective labor, the co-production of knowledge as a consequence of all kinds of instruments, satellites and weather balloons and ships and buoys and satellite ground stations and so on and so on. But I would like to focus on the specifics of this experiment. in 1974, and you see here the you see the ship and land observing network during the tropical experiment. And I would like to focus and zoom in on the ships. Very interestingly, you see both the Soviet Union and the United States working together here. You see not just those two superpowers, you see also the French, the Canadians, you see the Dutch. The Dutch had a ship as well, the Onversaagd. But especially interesting here are 4 German ships, 3 of them from West Germany and 1 of them from East Germany. They're all named after famous expeditions in the past, the Meteor and the Planet, all famous German scientists, cosmopolitan scientists, such as Alexander von Humboldt and the fisheries biologist Anton Doorn, who, by the way, was a good friend of Ernst Haeckel. These 4 ships worked together with the other ships, and very interestingly, when the East German ship and the West German ship had to communicate with each other, was always an American ship in between. So you see the West German Anton Doorn and the East German Alexander von Humboldt, and in between you see the Columbus Iceland American ship. And what they are doing here is measuring the atmosphere with the help of balloons. I'm going to talk about these balloons very soon, because these balloons are, I think, a key instrument. An easy way of explaining this, or a short-term focus on this event, would be explaining this as the consequence of the Cold War, as a consequence of the détente between the United States and the USSR in the 1970s. We see indeed, as a consequence of Nixon's visit to China, we see an opening up, a warming up of the relations between the Soviet Union and the United States. And you see them being more prone to working together to, well, study the global south. So we see cooperation to study the global south. We see famous Jacques Cousteau also being there. So it's quite a prestigious event, quite a prestigious act of global diplomacy. So how can science and technology be utilized in the solution of today's critical national and international problems? And at that time, it was not climate change, but measuring the climate, measuring the weather to produce reliable outcomes. And to understand the weather, we need to map its global circulation. And there's lots of data from the south we still miss. That's the kind of the mission of that time. But I think we miss out on a medium-term context that could explain this event. And I think that is this American space program that is partly building on German expertise. The director of GARP was called, his name is Joachim Kühner, was a German. He was born in Breslau, and he first did a degree in law, and after that he did a degree in physics in Hamburg. And he would end up in the 1990s as the director, or in the 1970s, the director of the Global Atlantic Tropical Experiment, and would after that work at the National Center for Atmospheric Research in Boulder in Colorado. And only recently, by the way, he passed away with 102 years. And this is a very interesting context. If we go back in the history and we look at the past, what did Kühner did before he did the experiment? He was very vital. He played a very vital role in setting up an environmental program in the space program of the United States. He was very focused on studying the human environment through space and creating satellites. So the space race is an important part of studying the climate and the environment. He worked together before that in the 1950s with the famous German rocket engineer Wernher von Braun, who called himself apolitical. He worked for the Nazis, but as Tom Lehrer famously sung, "Once the rockets are up, who cares where they come down? That's not my department," says Wernher von Braun. But this also seems to me a kind of historiographical dead end, because we now tend to focus too much on the Cold War military-industrial complex, and especially the role of German Nazi engineers in it. I think hidden under this story is even a longer story, and even a deeper history, I would say, a deeper history of I would say the German-speaking world as a pivotal player in the international network of aerology, and stratosphere mapping. And I think that, for me, what is very interesting for me is to go back to Europe, to go back to the early half of the 20th century, and focus on what I would call aeroculture. And that's a term that I've stolen from the German space historian Gebhardt, Alexander Gebhardt, who wrote about astroculture in the post-1945 history, and also a little bit before the Second World War, the culture of space exploration and space imagination. I'm much more interested in a technique that the kind of technology that you need to maintain this everything, the whole space race, the whole space program of watching the Earth, the environment of the Earth, namely aerological research, especially research with gliders and weather balloons and airplanes. And it's interesting to see that that's also the area where Kuttner is coming from. He played an enormous role in the glider culture, also first in the United States, but before that he was the chief of the Wetterwarte and the Zugspitze in the German Alps. But before that, he was he bombed. He was a bombing pilot in the Messerschmitt, also very important. But he played a very important role in a German nationalist culture of the 1920s of claiming the air, and of course, because of the Treaty of Versailles, the German meteorologists weren't able to use motorized flight anymore, so they started to experiment with gliders. And you see a large community of meteorologists happily taking the chance to use these flyers together with balloons to study the atmosphere in their own country. But even that has a longer history. It's a much longer history of weather ballooning and aerial meteorology. And going back to that GAR project, I think I'm very much indebted to the work of David Edgerton, The Shock of the Old. And one of the points of David Edgerton is, well, we tend always to focus on novelties, on new innovative technologies. We speak of the nuclear age, for example, whereas still 90% of the economy is being ruled by coal, and so on. And in the same way, I would like to propose that even the current climate of the current system of weather science is very dependent historically on older and much more much broader technologies, including balloons. If we focus on the global theater of science in the 20th century, we see a culture of ballooning, of weather balloons. The Germans sang a song in the early 20th century, Das Lied vom Gummiballon. It was as much a celebratory culture as a current space culture is. And it was not just a German culture. I mean, I focused on German nationalists and hang gliders, but they were attached to an international community, and a cosmopolitan community of Scandinavian, Austrian, and Russian, and American, and British, and French meteorologists measuring up the sky, with heavily investing in all kinds of stations and ballooning stations. I don't think that today we're going to need to go back to the Victorian age. we have already seen some studies on the history of aeronautics and aerology between civil science and civil science politics. So I won't go into that today, but I would like to focus on a very specific event in 1910. And I think here's where it all started. At the beginning of the 20th century, when weather science discovered the third dimension. As Ewout van Everdingen, who worked at the KNMI, told his audience, de derde afmeting in de weerkunde. And he said there are 5 ways of studying the higher atmosphere, because we need to study the higher atmosphere. First problem, we need to study the higher atmosphere. And there's 5 ways of doing that. One is manned balloons, but they're expensive and too dangerous in coastal countries because you drift away and suddenly you cannot land anymore. So we use kites. They're cheap, very Dutch, but useless when there's no wind. So instead we should use tethered unmanned balloons. However, they're useless when there's too much wind because there's a maximum of rope length. So let's use free-floating unmanned balloons. They can reach very high altitudes. However, you can only retrieve them in populated areas. And of course, you need pilot balloons to calibrate data with the other balloons. So actually, the solution is you need balloons, kites, balloons, balloons, and balloons. So I think the message is clear here. What happened in the early 19th century was they discovered a new layer in the upper atmosphere. It was designated by French and German researchers, and it was called the stratosphere. And it would start off a new discipline, the study of aerology. It was called by Vladimir Köppen. We all know from the Köppen climate categories at an international conference in Milan. And especially Germans were very keen on investing in all kinds of places to study this. And I will show you very rapidly a few slides just to give you an impression of the investments and the places where they did this. I'm not going to comment on all those slides because, well, there's not time, and such an amount of detail is too much for you, I think, at this time. We have in Hamburg, a German, the Deutsche Seewarte. We have an expedition in 1905, 1907 from Germany to the Bismarck Archipelago in German East Africa. Where they did measurements with weather kites and balloons. We have an aerological expedition to German East Africa in 1908. We have the opening up of a Royal Prussian Aeronautical Observatory at Lindenberg in 1905. We have the foundation of a meteorological observatory in the Alsace-Lorraine, the occupied area of France, where Hugo Hergesell, who became later president of the International Aeronautical Committee for the whole world, became a key player in a kind of scientific cooperation, a kind of scientific détente between France and Germany between the Franco-German and the First World War. What is it? What they produced? Well, they produced these kind of maps. Very interesting, but to show a much more dramatic image. What they were able to do now for the first time was really see the weather, really see the air for the first time. By measuring the air at different altitudes, they were able to, well, I wouldn't say predict storms, but at least they were able to prepare themselves somewhat for depressions coming from a specific place, and they were able to now to theorize about the relationships between different altitudes. So what we see here, and that's what I'm studying, is both a visible culture and an invisible infrastructure of maintenance and standardized fieldwork. And I think this is what historians bring to the Anthropocene, a historical sensibility. That's what Lisbeth also said. So this is what we bring. This is what we have to offer. But we should not only offer things. We should also adopt things. And one of the more important things that we should adopt is, I think, an atmospheric sensibility. I think we historians should more accept the things that we cannot see. We should not stick to documents and archives. I think we should also, especially in today's crisis, we should a focus on the aerial dimension of current and historical problems. We have a triple crisis of breathing now. We have the climate crisis, we have the COVID-19, but we also have Black Lives Matter. So I can't breathe. We remember that one. What's also interesting, we see also an increasing role of meteorologists and atmosphere physicists in human affairs. So they contribute in a way to, for example, understanding the spread of COVID, but they did so in the past as well. So I would propose historians to more fully adopt an atmospheric sensibility. And I think these aerial histories could become part of a larger form of environmental history. And of course, we see a kind of environmental realism. We see domains, we see land and sea and space. And from that perspective, and those things have already been studied well by historians of the environment. Bill Cronin's famous book on Nature's Metropolis, Helen Ross-Podolsky's book on the environmental history of the sea and knowledge of the sea, and Neil Mayer's book on the environmental history of the US space program. But we should do the same with the air and the atmosphere. And I think a future program, and again, students, I invite you to think about it, could be this: what is the nature of air? It changes. A scholar in the 16th century had different ideas on the air than a scholar in the 19th century. Does air have both a natural and a cultural history? This is a rhetorical question. Yes, of course, but how are we going to operationalize that? Can we speak of a Dutch air, for example? And I think this attaches to a larger agenda which we see emerge in the geo-humanities, especially in the British geo-humanities, but also in German and French political theory, the idea that there is such a thing as a constructed environment. So there are atmospheric things, there are bubbles, there are foams and globes we can sense. And it's very important when we discuss, for example, drones. What's the aerial element, and in what way does a drone claim the air, for example? There's much interesting research also being going on in the International Relations Department and the Conflict Studies Department here in Utrecht. So my last thing would be, could we create an aerial history of the Netherlands? And that's, I would say, a prize contest almost for you. And my question would be to focus on well, my interest is, of course, weather observation and calculation in the early 1900s. I'm very much interested in the way that this part of Europe, Central North Europe, was the most heavily observed part of the sky in the early 1900s, thanks to data from Hamburg, Lindenburg, Vienna, but also De Bilt and Uckel. But we could also tell a story of, I would say, for example, I'm just throwing something in the hat here. We could also do a history of early 16th, 17th century land reclamations, and it's not just by showing it's not just a history of the battle between land and water, but it's also the land asking the wind to help. It's about wind energy. It's about the Lion of Holland being attacked by the cruel water wolf and being helped by the Prince of Winds. It's the windmills, of course, that make the land, make the water turn into land. So personally, I would be interested in this element, for example. We could also think about people creating global airs and atmospheres through watching the weather in the 19th century, or people working in aviation and aviation law, right? Finding laws for how to operate and how to navigate the air, because it's also a very important place for airplanes. So to end, for me, the end, I'm always interested the most in global history. It's not just the history of Germany, it's not just the history of the Netherlands, but it's the history of the world, and it's the history of the environment. But especially Dutch history has a key role to play here. I think we have had, we've had access to places. We were privileged to study places in the past, to study its weather. And we have lots of archives of atmosphere scientists, weather scientists, and all kinds of other colonial scientists trying to study imperial spaces, and to finally end a very important place in that history is Batavia, where it was the first place in history in the tropics, where non-Germans answered the German call for measuring the tropical sky. And here at this place, for more than 20 years, lots of data was being produced by many people working to research the sky. And so I hope to have contributed to an interesting conference, and I'm now fully available for asking questions. I'll leave this slide. So I'm just waiting for questions, and I know, of course, that it takes some time to ask them, so I'll just stare into the camera patiently.
All right, thank you so much for your talk. There's actually, just because you just mentioned colonialism, somebody actually asked in the chat, is it okay if I read it out to you?
Yeah, of course.
All right, so somebody asked, was expansionism and colonialism important for the great investment in the German or other Western countries, such as France, atmospheric science?
It was, and you can see that because of, well, it's been demonstrated by, well, there's two ways of looking at this. The first aspect is more traditional, looking at German endeavors in the colonies. And that is the case, because what you see here is immediately in the first years of this program, you see expeditions being sent out into the tropics to German colonies, East German, East Africa, and to the Bismarck archipelago, where German New Guinea was. But they also worked together with traditional partners, traditional colonial partners, and the Dutch were very important. The Dutch Indies, as I've also studied in my Dutch laboratory history project, where lots of German botanists visit Buitenzorg, including Haeckel, there we have him again. We see that the Germans really built on colonies of other European powers here. So there's one part. But the other part here is, I think, and it's really important, that Germany always saw itself as an empire. It was a young empire in Europe. So it's not just about the traditional colonial empires, but it's also about Germany investing in countries around it, Germany investing in creating an imperial state, so also trying to, well, more centralize the fragmented landscape of competitive German centers here. So you see centers in the German, in the French occupied region of Alsace-Lorraine working together. And of course, in period of wars, that's the dark side of this project. In the First World War, German meteorologists were active in Belgium and in France. In the Second World War, they immediately, of course, internalized or occupied, conquered the Polish meteorological institutes. So we have to be careful, though, to see everything as a colonial effort, because it's in many ways it's not a top-down process. It's a bottom-up process of people finding each other, sharing the same commitments, and also many Germans peacefully cooperating with French and Russians during times of peace, and even in times of conflict sometimes. But Germany is not the only country. So the Americans, the Russians, they all have a kind of frontier mentality in this process. They also see the air as a new frontier, as a new space to be conquered. As is space nowadays. Is that answering your question?
Thank you so much. We are at the end of this talk right now. There are some more questions in the chat, actually. So if you would want to answer these, could you please go to the YouTube chat, and then we can you can answer those there.
I will.
Thank you so much again. We're now going to have like a 15-minute break till 20 to 3, and then we're going to continue with our program. We hope to see you all there.
Oh, I have a small question.
Yes, go ahead.
I still have USK muntjes. Can I still use them?
Yes, you would be able to use them.
Good. I'll save them then. Okay, good.
Fantastic. Thank you so much.
Okay, you're welcome.